Hello, my name is Anaika Mario, and in this video, I'll explain the rationale behind my essay on developing mathematical understanding and how instruction supports deeper learning in mathematics. So, the main idea of my essay is that mathematical understanding is not about memorizing procedures or getting correct answers alone. Instead, it is about building meaningful connections between mathematical ideas. So, for example, we may have a student that may correctly solve a multiplication problem like 3 times 4, but if they cannot explain what that answer represents, their understanding is limited. Another student who uses models like arrays or groups is demonstrating a deeper understanding because they can connect the concept to meaning. In my essay, I used three researchers to define mathematical understanding. So Skemp explains that there is a difference between instrumental understanding, which is just following rules, and relational understanding, which involves knowing both how and why something works. So I use this idea to show that real understanding goes beyond memorization. Nickerson expands this by explaining that understanding is shown when students can represent ideas in different ways, connect concepts, and apply knowledge in new situations. And this helps support the idea that understanding is flexible and usable, not just procedural. So, Barnby and colleagues take it further by explaining that understanding is a network of mental representation. So, I use this to show that the more connections students build between ideas, the stronger their mathematical understanding becomes. So I also explained a classroom process for developing understanding. So students need five main opportunities. So they constructing relationships, extending knowledge, reflecting on thinking, articulating their ideas, and making knowledge their own. So these steps are important because they move students from passive learning to active learning. Instead of just receiving information, students are building and reorganizing their thinking through experience. So, for example, when students solve problems using manipulatives, they are constructing relationships. When they apply math to real world problems, they are extending knowledge. When they explain their thinking to classmates, they are articulating understanding. And when they reflect their strategies, they begin to take ownership of their own learning. So, finally, I connected this process to the National Research Council's five strands of mathematical proficiency, which include conceptual understanding, procedural fluency, strategic competence, adaptive reasoning, and productive disposition. So these strands show that mathematical understanding is not one skill, but a combination of knowledge, reasoning, and attitudes working together. So, overall, my rationale is that mathematics should be taught as connected and meaningful processes rather than memorization of steps. So, when students are given opportunities to reason, communicate, and reflect, they develop deeper understanding and confidence in mathematics. Thank you.